Hello, my name is Erica Medina, and I am a student from the University of Houston downtown. The book that I'm about to read, it's called What Makes a Magnet by Franklin and Brantley, and it's illustrated by True Kelly. I chose this book because I feel that it's easy to read, easy to understand, and it gives lots of great examples about magnets and their actions of why they attract or repel to different objects. What makes a magnet? Let's go fishing with a magnet. Put different things in a box: a penny, a nickel, and a dime, a twig, some tacks, and paper clips, bits of aluminum foil, rubber bands, pieces of paper, and a pen or two. Next, find a magnet. They come in different shapes and sizes. Tie one end of the string around your magnet. Tie the other end to a stick or a pencil. This is your fishing pole. Go fishing in the box. Put the things you catch in a pile, and the other ones will stay in the box. Everything you lift out of the box is made of iron: the tacks, the paper clips, and the pen. The magnet won't pick up a twig, rubber band, aluminum foil, paper, a dime, a nickel, or a penny, because they're not made of iron. Dimes, nickels, pennies, and aluminum foil are made of other kinds of metal. A magnet picks up only things that have a lot of iron in them. You can make your own magnet with a needle. Needles are made of steel, which is mostly iron. Handle the needle carefully so you don't stick your finger. Hold the eye of the needle. Stroke the needle along one end of the magnet. Move along the magnet in only one direction from the eye of the needle to the point, not back and forth. Do this 20 or 30 times. Your needle magnet is a little one, but there are very large magnets. In fact, the whole earth is a magnet. Can you prove it? First, use your needle magnet to make it compact. Get 2 small pieces of foam, plastic, or cork, and stick a piece on each end of the needle. Carefully, don't stick yourself. Then float the needle in a bowl of water. The needle will swing around so one end points north. Keep the needle in the center of the bowl so it can swim freely. Turn the needle around. When you let go, the same end will again point north. Put a dot of ink on that end, and you have made a compass. The ends of the magnet are different. One is called the North Same Pole, or simply the North Pole. In your compass is the one with the ink dot on it. The other end is South Same Pole, or simply the South Pole. Magnets are strongest at the poles. When you pick things out of your fishing box, they stuck to the ends of the magnet, not the middle. Your compass points north because the earth is a magnet. The north same pole of your compass points towards the north pole of your earth magnet. No matter how you turn your compass, it would always point north when you let go of it. The earth is a magnet because it contains lots of iron. The moon does not have as much iron, so it is not a magnet. Your compass would not work on the moon. This compass doesn't work. We are lost. When people go hiking in the woods, they take a compass with them so they don't get lost. It tells them which direction is north so they can find their way back home. Airplane pilots and ship captains also use compasses so they don't get lost. Long ago, people did not have compasses, so they were often lost at sea. Then, a special kind of stone was discovered near Magnesia, a city in ancient Asia. These stones were called magnetite. When a piece of magnetite was hung at the end of the thread, the rock pointed north. The magnetite acted just like the compass you made with your needle magnet. A sailor put a mark on the north end of the rock. Ships used the rocks to help them. They could find their way even when they were so far out at sea where they could not see the land. Pieces of magnetite are natural magnets because they contain lots of iron, just as your needle does. Magnetite compasses were often called lodestones or leading stones, and you can see why. Now that you have made a magnet and a compass, you can make even more discoveries. Make another needle magnet just as you made the first one. Move the point of your new magnet close to one end of the compass. The end with the ink dot on it don't touch the compass. The compass may move toward the needle, it might be attracted, or the compass might swing away from the magnet and it might be repelled. You find that two north-south poles repel each other. Also, a north-south pole and a south-south pole attract each other. Like poles repel each other, unlike poles attract. Like poles repel, north-south poles attract. When you made your magnets, you use needles because they contain iron. Suppose you had tried to make a magnet using a penny or aluminum foil. You could have struck it across the magnet all day long and it would never have become a magnet. It will magnetize. Now you tell me? Why is that? Why can only iron become a magnet? Scientists are not sure why this is true. Maybe it's because the smallest bits of iron in a needle are like small magnets that point in all directions. When you struck a needle across a magnet, the tiny magnets line up. The magnetism of one particle is added to another, making the magnetism stronger. But the magnetite from Magnesia is magnetic and no one struck it with another magnet. So there must be some other way that things become magnetic. Magnetite is a natural magnet. Remember, magnetite contains a lot of iron and the rocks have been in the ground for thousands of years. Scientists think that the Earth's magnetism has been slowly moving the tiny bits of iron in the rocks, lining them up just as the particles in your needle lined up. This happens because the Earth is a great big magnet. So over thousands of years, the Earth might be able to make magnets out of things that have lots of iron in them. Magnetism is everywhere on this earth of ours. It goes through air and water, glass and walls, cardboard and tabletops. You know this because your compass works just about everywhere. Try it and you'll see it for yourself. The end. What makes a magnet? Once again, by Franklin M. Brantley, illustrated by True Kelly.